a nautical mile is from the center of the earth if I go exactly 1 minute of angle. This distance here, this is exaggerated obviously, is 1 nautical mile.
What is that?
It's a little more than a mile. Way over
the rest of the world measuring instead of knots.
We'll get to knots. So this is where a nautical mile comes from. So every 1 inch, every 1 foot minute, every 1 minute of angle is going to translate to 1 nautical mile on the earth. A knot is a nautical mile.
K-N-O-T.
K-N-O-T-T, did they really?
1 T.
Is that not very far? It's a nautical mile per hour. So instead of miles per hour, a knot is a nautical mile per hour. That's where that comes from. We had to convert everything into all this. It was a mess. Yeah.
So the rest of the world is the metric system?
As far as pilots go and stuff like that, it's possible they still use this because America kind of
What is
created
that
it.
called? That's too far.
Wait, what's this?
Scientific. Bullshit.
We call it the American Standard System, but I'm not sure this is part of the American Standard System. This is sort of its own thing.
Why do we use a different system in the rest of the world?
Because Britain gave us their system. Remember the inch? Yeah. That was there. We took everything from paper. And then eventually Britain changed to metric and we stayed the same.
They have teeth.
So let me tell you
Damn white
this
people
too.
thinking they're better than everybody.
One more thing with the units. So what they used to do was they would say a bucket of water would represent a certain mass. And what they would do is they would say this bucket of water, when you put it down, it represents a certain mass. So when we measure grain or something like that, it's all based on this bucket of water. King John years ago kept messing with that amount so that they could tax people more money. And as they kept changing that, the people got angry. And his wife was named Jill, and the nickname for John was Jack. And so they made a rhyme. Jack and Jill went up a hill and fetched a pail of water. Jack fell down and lost his crown. It was like a threat to the monarchy that we're gonna attack you and we're not gonna put up with this anymore. So your little nursery rhymes there.
Better get your bucket straight.
Political statement. I know a lot of stuff. Most of it's not too useful. Most of it's useless. All right, moving on. So I'm going to talk about the last piece. This is my last new lecture for you. We're going to talk about the, I know, for now. This is the average of a pump. And here's what we mean by this. Here's my function f of x. When we say average, we are referring to the range values, also known as the y values. I'll tell you another story in a minute about when I was a programmer.
Keep coming.
So between a and b, we want to know what the average of this function is. Well, you can see it's probably going to be somewhere about there, somewhere. If we average out all the different y values. But we want to, of course, mathematically figure that out a little bit more accurately. So what we're going to do is we're going to take samples. And so on. It's just the F version of that there. In between each is a delta x. That's the spacing. A is x naught, B is x of n. All right, so I want to do this. I want to recall that this formula you've seen a couple of times. It should start making a little bit of sense. If I subtract the 2 and then divide it up by n, that's going to give me my distance across for each one. That's my delta x. I'm going to keep that in mind. So what I'm going to do to find the average, f average, means I'm going to go f naught, f of x of 1,
Cold.
and I should make this approximately equal to. Actually, let me start. Not muddy it up. That's how you find the average, right? You add them up, divide by n. What's up?
Is that x n minus 1 on the before
N minus 1, yeah.
Okay.
Meaning it's the one previous to n.
Oh, I see.
Yes?
Why is that not exact?
Because we're just picking bits and pieces. It's going to be exact if we shove n to infinity, which involves a limit, which we're going to get a ream on some here in a second. All right, so as we're looking at this, it's approximate, again, because we're just picking bits and pieces. If delta x is like really large, it's not going to be as accurate. Because if we did this, if we found one here and then found one here, we're missing a huge chunk there. That's really going to affect the outcome. So the more data points we hit, the better. So I'm going to say that f average is going to be equal to, let's see,
Ooh. I know. Okay.
Is that n to infinity?
is what?
Is that n approach the limit to infinity?
Yes. I'm going to rewrite this a little bit. Yes, sir.
So it, the sub x sub what?
K.
And then k equals 1, is that right?
K starts at 1.
Yeah.
So I'm going to do some magic here over here. I don't know where I put my winner actually. All right. I'm going to say that 1 over n is equal to delta x over b minus a. I'm going to let you figure out that algebra here just for a second. Then I'm just going to plug this down a little bit. Oh, no. Have you figured out that algebra? You can switch the delta x and the n and then flip them both. So I'm going to replace that here. Oops. Yeah. And rewrite it like this. I replace the 1 over n with that, and I just move the delta x over here. It's like distributive property. which we now see is a beautiful, and here's the formula, wait for it. I've only used the average of a function 2 or 3 times ever. Okay? It's not that interesting, that's why this is the most interesting part of my opinion, is deriving it. And let me grab the example out of the book. So if your test is up here, I'm going to put it there during the break. So. All right. By the average of f of x equals 1 plus x squared for x going from -1 to 2. After you copy that down, would you please graph that? What does the shape look like, by the way? It's a parabola. Is it facing upward or downward?
Upward.
Upward.
So that's what you guys did earlier on Tuesday with a lot of graphing.
Yeah. And equations. That should be a bit.
Do you not go for the average minimum of dx?
I didn't put dx? Oh, if this is dx. For sure dx. Change that.
Change that.
Sorry. Delta x becomes dx as n goes to infinity. Sorry about that.
I'm so tired. Can't this be over?
Again, you're only graphing it from x equals -1 to 2.
Starting.
Are you with me on the graph? All right, so let's find the average of the function. Go ahead and try to use the formula, please, and come up with what is the average of this function based on the information given.
Your graph is wrong. Stops at 1. Stops at 2.
That's what I did. I just.
Lies. Can you hear my tummy growling on YouTube?
Seriously? Come on. It's like not even trying.
1 plus 1 equals
The average is 2. drafting, get asked, what do you use this for? I'll just say stuff.
Stuff.
It's popped up here and there occasionally. In fact, I remember doing one word problem, and after 20 minutes of reading it, I'm like, and then it clicked, I'm like, oh, they're asking for the average. And so I had to go back to my old calculus book and look up the formula. How are we doing? All right, that is the end of the new information for today. We're not done. I do want to go back through and do a